Hello there. Today we'll be doing number 82 of our 150. So this is Pacific Atlantic water flow. In this particular problem, we will be given a grid where water we're tracking for water that can flow both to the Pacific and the Atlantic Ocean. And as you can see, this is a graph problem, and we're looking to see if any of these nodes can reach the ocean. A simple way to do this is that if we just check for all items that touches the Pacific Ocean, and if we work inwards towards all the items that can reach the Pacific Ocean, and we look at all the items on the Atlantic Ocean and that can touch the Atlantic Ocean, we get the intersection between the two. We can get all the items that can eventually get to both the Pacific and Atlantic Ocean. So with that in mind, let's get the code going. We're going to be doing a DFS. So what we're going to do first is that we need rows and columns so that we know our bounds. So once we have that, we want to get the Pacific and the Atlantic as sets, so that we know where we have visited and what we have done. By having these visited sets, we know exactly what's inside the Pacific Ocean, and if we have visited, we need to visit a second time. So we're gonna look at all the rows first, and so for not for all the rows, but just look at each the top row and the bottom row. So that means we're looking at columns. And what happens here is that we're going to run DFS, and on that particular problem, where we look at the 0th row and the column, and we need the visited Pacific, because this is the Pacific Ocean at the top, and we need the current height. The reason why we need the current height is because the next height, we'll look at this particular height and see if this is a lower or higher. If it's lower, then if the next height is higher or equal to, then it's okay to keep adding on to the visited Pacific. It can reach Pacific, otherwise it cannot reach, and then we can cut that part off. So that's why we need that variable. So columns -1 is the last row. No, wait, sorry, rows -1 is the last row, and that's going to be Atlantic. And we take the height of the rows -1 and the columns, and we complete that option. So for rows, so we're going to check each column, the first column and the last column now, and we're going to start from there. So DFS, we're going to do a row and columns, 0, and this is Pacific, because this is the left side. Height is equal to R and 0. So not C, 0. So same thing here, DFS. We're gonna get the row and columns -1. We're gonna get the Atlantic and the height of the row and the constant -1. So with that, we can return the intersection between the two, which can be done like this. This is a list, and we do Pacific and the Atlantic. And that is how we do Python. So anyways, let's define the DFS now so that we can clear all the visited nodes. So we have R and C, and we also have the visited. We also have the previous height. With that, let's say get the base case going. So R is less than 0, or C is less than 0, or R is greater than or equal to row, or C is greater than or equal to row, columns, or it's in the visited, so R and C is in visited, or the height of R and C is less than. If it's greater than or equal to, it's fine. If it's less than, then that means this current height is too low to pass water to this particular piece of the ocean. So this is the previous height. We're going to return, and if it passes, then we're going to add RC into our visited or Pacific Ocean. That means we can go from this particular location into the ocean, and we're gonna test the next 3 places. So what that means is that we're gonna test well, R and C, and we're gonna do a +1 later, visited, and this particular current height, previous, which is height of R and C. And so we're going to copy and paste this 4 times. The thing I like about code that is written lazily is because it is the most clean, and people will like gravitate towards that type of code, writing this type of code. And I think it's easier to read because people are used to writing it. So with that, we have visited all our nodes. We have put them onto visited, and we have visited both and created both sets. We have a syntax error. Let's see what's going on. Def DFS. Okay, we have an issue here. Let's see, HIGHTS, heights. We're missing the S in heights, which is not good. I think there's a way to... Oh, I don't think so. Not here. Okay, just put the S in. All right, run the code. Oh, this is wrong too. Set dot add. There we go. Yep, perfect. And let's run the code. Perfect. And that's how we solve Pacific Atlantic. If you check out this code, it looks super clean. Well, I might be just praising myself too much, but if you think it's super clean, I think so, because I checked the other submissions in the discussion section. It looks horrid. So in this particular problem, what we learned is that we could shrink the problem and look at what get to our end goals first, and make sure always look at where our end goals are, just like the islands with the ones, and just like anything else. That's where we start, and that's where we create visited. This is the first time we did visited nodes, visited sets, rather than just altering the scope of the graph, because we cannot change the graph this time around, because if we did, then we won't be able to do this problem. So we use the sets, and with that, we have solved this problem pretty quickly. I hope you enjoyed the video. If you do, like and subscribe. If you want more videos, check the link in the description below, and I will see you in the next one.